Now see the part 6 of ionic equilibrium. Part 6 of ionic equilibrium. Next question is 17. Ionization constant of acetic acid is given. Ionization constant of acetic acid CH3COH is equal to 1.7 into 10 raised to minus of 5, and concentration of H plus is given. Concentration of H plus is given, that is 3.4 into 10 raised to minus 4. Then find out the initial concentration of acetic acid, right? So you have to find the initial concentration of acetic acid. This value you have to find it, right? It is asked in 2001. Asked in 2001. So now see the explanation. So when acetic acid dissociate, suppose I am taking the reaction CH3COH, it dissociate into CH3CO minus plus H plus, right? So write the equilibrium constant for this reaction. So Kc is equal to CH3CO minus into concentration of H plus divided by concentration of acetic acid CH3COH. Understood? So as we can observe, concentration of these acetate ion and H plus is same. You can write here also. Concentration of acetate ion and concentration of H plus ion is same. Then it becomes concentration of H plus ion square divided by acetic acid concentration CH3COH, right, is equal to Kc. Now we don't know this value, this part. We know this and this. So put the value, then you will get CH3COH as concentration as Kc upon concentration of H plus ion square. Kc value we know, that is 3.4 into 10 raised to minus 4 whole square divided by H plus ion concentration. That is how much? It is given see here, we have done here mistake. We are finding this, right? So this will be the inverse of this, no? Right? Because concentration of H part will be in the numerator, right? So I have written in the inverse. So I have put the value of H plus ion concentration. That is, it is given here. It is 3.4 into 10 raised to minus 4, right? So that one will be the square. It is written here, right? The value of Kc is given. This is the Kc value of acetic acid. Now put this value, so it will be 1.7 into 10 raised to minus of 5. Now calculate, then you will get the concentration of acetic acid. That will be 6.8 into 10 raised to minus of 3. So this is the answer. Please write this explanation. Now look at the question number 18. So 18 is, which one of the following is true for diprotic acid? So that formula is H2X. This is the general formula for diprotic acid. It is asked in 2000, right? So it is asked in 2000. So let's see the explanation of diprotic acid H2X. Diprotic means it produces 2 hydrogen, right? So in the first step, it is producing HX, right? HX minus plus H plus. Equilibrium constant for this reaction will be Ka1. Right. In the similar manner, this is the first step. Second step will be Hx minus will produce H plus plus X2 minus, right? Minus will be increased by 1. So this will be the equilibrium constant Ka2, right? So in the first reaction, H plus comes from the neutral atom, right? So this is the acid, right? Initially it is neutral, right? While in the second, H plus comes from the anionic part. This is already anion, right? Minus sign is assigned there, or it is given to it, which is difficult as compared to first reaction, right? So dissociation constant will follow the order like this. Ka1 will be greater than Ka2 because K1 is coming from the neutral acetic acid. So that will be the answer. Now see the question number 19. Which of the following statement about pH? It is asking about pH and H plus ion concentration is incorrect. It is talking about incorrect statement. So let's see the statement. So right, so let's see. So HCl is a strong acid, right? So HCl is a strong acid. Why it is a strong? When it dissociate into cation and anion, it completely dissociate. That's why. When any compound completely dissociate, that is a strong acid. Dissociate. That is the strong acid. Understood? Now see. Next one is NH4OH. So this is your weak base, right? Weak base. So when any compound is weak, then it is dissociated partially. So it will be dissociated partially, right? So next statement is addition of HCl, right? When HCl is added to NH4OH, right? Concentration of H plus ion increases. After adding HCl, what happened? Concentration of H plus ion increases, right? And pH value decreases. As the concentration increases, pH decreases, right? I will tell more about the pH. Suppose this is your pH scale starting from 0 and ending to the 14. This the pH, right? Here it is 7. 7 pH means it is neutral compound. So it will be the neutral compound, right? So when pH lies between 0 to 7, it is called acidic compound. And when it is lies between 7 to 14, that will be the basic compound, right? So more the concentration of H plus, pH will be less, right? Suppose it is starting from 1, 2, 3, 4, 5, 6, 7, like that. So pH will be lesser. So uh, near to 0 and 1, that will be the strong acid, right? And near to the pH of this one is, that will be the strong of base, right? So according to the pH, we know the formula now. It is defined as pH is equal to minus log of H plus ion concentration, right? Now see the next case. When we are taking that acetic acid, suppose CH3COH, right? So this is the weak acid, weak acid. So what weak compound do? It partially dissociate, partially dissociate, right? And now this is your weak acid, and suppose I am taking NaOH, that is a strong base, strong base. Understood? So in this solution containing one equivalent of each, there are more OH minus ion, right? When it dissociates, suppose Na plus, OH minus, right? So OH minus ion is more than H plus ion. So this is more. Why? Because OH is also coming from acetic acid. When this acetic acid dissociate like CH3CO minus plus H plus, right? So this will be the more ion due to strong base, right? And this is your weak base, so it will partially dissociate, right? So in this case, in this part, what will be the strongest part? OH minus ion, right? So pH is more than 7. So what will happen? pH value will be more, right? It is due to the weak acid. Thus statement is incorrect, right? So that will be the incorrect statement about the B option. Next point is pH of pure neutral water is not 0, right? So pH of water is not 0 because it is neutral. So pH will be equal to almost 7, right? Cold and concentrated H2SO4. Suppose I am taking H2SO4 in two phase, cold and hot, right? So the lower of H plus ion concentration in the condition it exists mostly in unionized form, right? So when H plus ion value is lower, then it dissociate into lesser H plus ion, right? Because in this condition it exists mostly in unionized form, while when diluted it completely ionized to give H plus ion, right? So write this whole explanation now. Now see the question number 20. The conjugate acid of NH2 minus is there. So it is your base, right? So when it dissociate, it form conjugate acid, right? So for conjugate acid, extra H plus should be there, right? So what should we do? We should add H plus to this base, right? So this is H plus. So it want now lone pair. So oxygen, nitrogen having lone pair. So it will get attached to this lone pair, or there is minus sign and there is plus. So it will become neutral after forming NH3. So NH3 will be the conjugate acid for that one, right? So, or next see the more explanation about it. So NH2 minus is there, this is base, right? So what it does, it accept proton as it is base, right? So what base do? It accept the proton and it will form the conjugate acid and form conjugate acid. Thus, according to the above chemical equation, it is NH3. So it will form NH3 after accepting the H plus ion, which is conjugate acid, right? So it will be called as conjugate acid. So please write this explanation. Now see the next explanation. Question number 21. A strongest conjugate base it is talking about. Conjugate base. That should be strongest, right? So see here, weaker the conjugate acid, stronger is the conjugate base. So this statement should be valid. So it will be weaker the conjugate acid, acid, a stronger is conjugate base, right? So see here NO3 minus is there, right? When it accept H plus, so this minus and plus will get neutralized and it form HNO3, right? So H is attached here, so it forms HNO3. So this is the weaker conjugate acid it is forming, right? Minus sign is there, that's why it is base, and H plus is there, then it is acid. So base is forming now conjugate acid, conjugate acid. Now see the next part, that is Cl minus. When it react with H plus, it forms HCl, right? So again it is base, Cl minus, again it is acid, so it is attached to this one. So this is your conjugate acid, right? Now see the next one. Next one is SO4 2 minus. It react with H plus, right? So one is neutralized, one sign will be remaining there. So it will form HSO4 minus. That will be the conjugate acid, right? Now see the acetate ion explanation. CH3CO minus react with H plus to form the acetic acid, CH3COH. This is your conjugate acid, right? So among the given conjugate acid, acetic acid is weakest acid, right? It is forming the, because why it is weakest? Because it is coming from the carbon compound, weak acid. So its base will be strong, right? So it is talking about conjugate base. So it the acid, so acetate ion is the strongest base. So this will be the strongest part, right? Strongest. So please write this whole explanation. Now see the next question number 22. So concentration of H plus, concentration of H plus and concentration of OH minus ion is 0.1 molarity aqueous solution. What is that one? That is 0.1 molarity of aqueous solution of 2% ionized, 2% ionized monobasic acid. So that is monobasic acid. So, and as we know, ionic product of water is given, that is 1 into 10 raised to minus of 14. So this is the ionic product of water. Ionic product of water. Right. So see the next part explanation, right? For generally we represent acid as Ha, right? And it dissociate into H plus A minus, right? So H plus ion concentration will be the concentration into alpha, that is degree of dissociation. So for finding the H plus ion concentration, we know that is 0.1. So it is given 0.1, and alpha value is also given, that is dissociated 2%. So it will be 2 upon 100. So after removing this point, you will get 10 here in the denominator. Then H plus ion concentration will be 2 into 10 raised to minus of 3. So this is your H plus ion concentration, right? So now see the dissociation constant for water, that is given 1 into 10 raised to minus 14. So it is nothing but it is concentration of H plus ion into OH minus ion. So it is 1 into 10 raised to minus 14 is equal to, put the value of H plus ion concentration from this equation. That is how much? 2 into 10 raised to minus 3, and get the OH minus concentration. So OH minus concentration will be equal to 1 into 10 raised to minus 14 divided by 2 into 10 raised to minus 3. So it will be OH minus concentration. So how much it is? It is 5 into 10 raised to minus of 12. So cancel this one, then you will get the answer, this part, right? So answer you have got for OH minus concentration is 5 into 10 raised to minus 12, right? So its unit will be molarity, concentration unit is molarity. Now look at the next question, that is 23. If alpha is the fraction of HI associated at equilibrium in the region, so when 2 HI dissociate, it forms H2 plus I2, right? Starting with the 2 moles of HI. So it is starting as 2 moles of HI. Then the total number of moles of reactant and product at the equilibrium. So very simple question. Initially it is taken 2, right? So this is your initial mole when it is H2 and O2 doesn't form, right? So that will be the 0 value, right? So what will happen at equilibrium? So let's see at equilibrium. So it will be 2 minus 2 alpha. This will be the 2 alpha by 2. Then it will become alpha. And for I2 it will be 2 alpha by 2. That is the alpha. So total number of moles you can calculate easily. Total number of moles. So it will be how much? It is equal to 2 minus 2 alpha, right? So no need to multiply, just write the alpha, because it is coming out to be, here coefficient is 2, that's why we have multiplied here 2. So it has reduced 2 minus 2 alpha. This will be the alpha and this will be the alpha. So total number of moles will be addition of these 3 part. So that will be 2 minus 2 alpha plus alpha plus alpha, right? So this is the addition of 2 alpha. So total number of moles, that will be the 2 only at the equilibrium mole. Okay, so write the answer. Now look at the next sum, 24. So pH of 10 molarity solution of HCl is, so pH of 10 molarity of HCl. So let's find the value of pH of 10 molarity HCl. So it is very simple. So we know the value pH is equal to minus of log of H plus ion concentration. So it will be minus log of H plus ion concentration, that is given. That is 10, right? So put here 10. So it will be 10. And base is also 10. So log to the base 10 is 1. Right? So it will become 1. So pH we are getting as minus 1. So it is less than 0. Right? So that will be the answer for 24. Less than 0. It is asked in 1995. So please write it down. Now look at the question number 25. Aqueous solution of acetic acid contain. So there is acetic acid CH3COH. Right. So this is your acetic acid. It dissociate into CH3CO minus plus H plus ion. Acetate ion and H plus ion. So, and when it is also react with water, so it is talking about aqueous solution, right? So I will use here water. So what will happen? This H plus ion will attach with this lone pair. Then it will become H3O plus ion. That is hydronium ion. Right. So that will be the hydronium ion. This is called hydronium ion. Does the aqueous solution contain three type. First will be this will be the acetate ion and then hydronium ion, right? So that is the aqueous solution. Aqueous solution. Please write it down.